Okay, so we have AND gates. We usually use them to decode active high outputs, yeah, from the counter. So in this case, you're given a mod 16 counter. When you think about the mod 16 counters, we do our usual thing. We get the flip-flop number. So your mod is 16, 2 to the power n. You put n down and call log 16 with base 2. You go back to your Excel and then put that in here, yeah, equal to log and then 16. So 16 base 2, and you will get 4, yeah, so we get 4-bit. Let's go back to our problem here. So we need 4-bit, so I have 1, 2, 3, 4, and these are my input A, B, C, and D, yes? So now your question is telling, oh, there is a LED, yeah, on when the count equals to 13. And we're going to assume D is our MSB. So let's write that down. This is MSB, meaning like put it to the left, yeah? Higher order. And then your A, of course, is your LSB here. And your AND gate used to control your LED, yeah? Because AND gate is doing decoding the state to human readable, human sensible form. So most of inputs are, let's see, so what kind of input are we going to have for 13? So 13 decimal base 10, we're going to change it into binary. We have 4 bits. We can write 13 for 4 bits. We can write all the way to 16, yeah, with 4 bits. So we go 1 for 8, 1 for 4, and 0 for 2, and then 1 for 1. Your position, 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3 right here, yeah? So value again, position 4 here, 8, 4, and then 2, 1, yeah? So I have 1, 8, and then 1, 4, and then 1, 1. We don't have a 0 here because we're making 13 in decimal. So 8, 4 is going to give you 12, yeah? And then 1 is going to give you 13. So altogether 8 and 4 and 1, when you add them up, you're going to get 13. We don't have to count 2 because I don't have it, yeah? If you count 2, it will become adding 2 to here, yeah? It will be 15. So this is 13 in binary, so 1101. And when you look at our output, okay, since AND gate is decoding this output, we know what output is going to be because we want to display 13, yeah, decimal on your LED. And your AND gate is decoding this state. The state we have is high, high, low, and high right here, yeah? So therefore, if we write it in the output, okay, with a letter output, we can write it, one is D, and then 1 is C because we are at the position, yeah? C, flip-flop, D, flip-flop. And B, we don't have anything because it's low, yeah? Because we want to display 13, okay, on your LED. This is your LED. And decoding is done by your AND gate, okay? It's not very, I think I should just write it. It's trying, it's a little. So anyway, so this decoding from state to LED is done by your AND gate. So my state is high, high, and then low, and then high right here. So I have DC, not B is going to be 0, yeah? And then your A, okay? So this is on, and then off, and then on. and that will decode it on your LED as 13. Okay, try to just memorize your 1 and 0, like 1 is if 1 is D, then D prime is going to be your 0. Okay, so I can write that down for you. So if you can be able to remember all the stuff, then you can remember like this. Okay. Okay, so if your state is 0, then your output is D prime. If your state is 1, your output is D. Okay. All right. So the answer is, when you look for the answer here, D, and then it's the same, D, and then C, and then not B, and then A. So when you look at it, you know that it is displaying 13, because it said it, so there's 8, and then that's 4, and then this is your 4, and then, this is your 2, and then this is your 1, 2 is off, it said it so here, 8 is on, 4 is on, and then 1 is on. So 8, 4, and 1 will give you 13 for decoding, for human readable value. Now this is your state output on your flip-flops right here, on your circuit right there. It can be represented with your binary number 1101, state DC, and then not B, and then A. Okay, your logic. Alright, so that's for this answer.